So finally, let us start. I'm glad to see you all today. And the topic today is data science in retail. My name is Polina Polunina, and I'm an independent consultant in data science and digital transformations. Today we are going to speak about the three main points. First, we'll speak about what advanced analytics and data science actually is and why everybody wants to develop advanced analytic-based solutions. Then we will move to the second part about what kind of problems exactly in retail and QSR, which is quick service restaurant sphere, could be solved by advanced analytics. And then we will move to the third point, what could be your place in a development team. A few words about me. So as I already said, my name is Polina, and my career track is twofold. So first of all, I am an expert in data science, and secondly, I am a teacher. So speaking about my expertise, I started nearly like more than 10 years ago. My first position was an intern in Unilever, which is an FMCG company. And that was even before all this hype on data science was set up. And then I moved to the quantitative trading sphere. I used to be a quantitative researcher in a worldwide mutual fund called Quant. Then when the hype on data science and so on was stopped, I decided to develop some skills here also and moved to retail. My first position was a lead data scientist at X5 Retail Group, which is a leading retailer here in Russia. Then I used to be a head of data science at another huge retailer in Russia called Videoanalytics Group. And then I moved to McKinsey to advanced analytics practice, and now I decided to set up my own consulting practice. So now I am an independent consultant. Also, speaking about my teaching career, nearly 4 years ago, I started at Higher School of Economics as an invited lecturer in data science and machine learning. Now I have different positions simultaneously. I'm an academic director of the joint master's program in data science at MISIS. Also, I'm a teacher at Moscow School of Management at Skolkovo. I'm a member of State Examination Committee, lecturer at Higher School of Economics, and I also teach at many universities here in Russia and some platforms. So again, nice to meet you all. Let us move to our first point. What is advanced analytics, data science, artificial intelligence, and why it's important? What is advanced analytics? This is just a common name for all the data sphere. So advanced analytic systems is just a digital product that is based on data. Maybe some time ago, you saw a movie called Terminator, especially Terminator 2. And if you could remember, there was some artificial intelligence system called Skynet that was aiming to kill all the living beings worldwide. When we speak today about artificial intelligence system, about machine learning based system, advanced analytic, anything, you could be sure that nowadays there is no systems like Skynet. Maybe GPT-3 or GPT-4 some days like would present some danger, but not now. So machine learning is just part of the artificial intelligence sphere that consists of the algorithms, well-known algorithms. Some of them was developed like many decades ago, and these systems can't operate without human. So nowadays we need human to set up a problem, to find the data, to prepare the data, and then to train some algorithm and to insert it to some user interface. So there is no, again, independent systems like Skynet, but still we have some useful systems that could present and add some value to the business and research sphere. Speaking about deep learning, this is just a subpart of artificial intelligence domain that is focused on neural networks. So when we speak about machine learning, we speak about all the common algorithms like linear regression, support vector machines, decision trees, anything. And when we speak about neural networks, we call this deep learning. Okay, this is about basic things. And today also we'll use some shortcuts. And I would like to briefly explain these abbreviators. So AI is artificial intelligence, in Russian, искусственный интеллект. ML is machine learning, машинное обучение in Russian. DL is for deep learning, DS is for data science, BI is for business intelligence, and also we have AA, it's for advanced analytics. So what data science is exactly? It lies on the intersection of three subdomains, which is mathematics, computer science, and some domain expertise. When we speak about mathematics, we mean explicit formulas that is core of some specific algorithms. When we speak about computer science, we mean specific languages like SQL or Python or R, or maybe some other languages that we use to write the code for our system. And the third one is domain expertise. It could be different. So let me provide an example. So suppose that you are a data scientist at some retailer. Besides mathematics and computer science, you also need to know some specific of this business, just to be sure that your algorithms will lead to some value. So if we speak about retail, the domain expertise would be some retail-based metrics and knowledge beside of that. If you're a data scientist at, I don't know, it's our bank, the domain expertise would be banking. If you're a data scientist in some biology startup, so your domain expertise would be medicine or something related. To be successful data scientist, you need to combine all three parts of the knowledge. Excuse me. Sorry for that. Okay. Speaking about the data science, we could divide on the sphere for two subparts, for two different subparts in terms of timing. So when we look to the past, we usually speak about business intelligence. When we look into the future, we usually speak about some forecasting. And if you or when you will be applying to some positions, you could see some different, very different sometimes like names for these positions. And just be sure, explicitly. Okay, let me explain. So there is a difference, there is some difference in like more Russian word and more European word. So when we speak about data science career here in Russia, we usually talk about some machine learning based database specialists. When you see the position data scientist worldwide, it could relate to like any analytics positions, from like simple analytics to some machine learning and neural networks expert. But here I would like to provide the border between business intelligence analyst and between a data scientist. So when we speak about business intelligence analyst, we speak about some like simple algorithms that is used to explain the data that you already have. So we look into the past, and the questions that could be asked here is what happened and why it happened. When we speak about data science, and further into the presentation, we will ask questions and raise questions like what will happen in some period? What should we as a business do with this information, and how the use cases could be set up here to be sure that we will reach some, I don't know, points on the profit side, for example. And now let me explain why data science has that hype, and why like everybody wants to integrate and develop some solutions. So this is the screenshots from the McKinsey Advanced Analytics report. And here on the slide, we see the revenue increase dynamics from AI solutions adoption. So what we have on the left, here are listed some functions. Then we have some data to compare between 2 years, and also we have some colors. We have like deep blue, moderate blue, and light blue. So deep blue color refers to the increase in revenue that is less than 5%. By moderate blue color, we mean like some moderate increase from 6% to 10%. And by light blue color, we map the increase in revenue that is more than 10%. And basically, what exactly we could like transfer from this slide? First of all, the effect of successfully integrated AI use cases is more than 10%. Secondly, we see some increase in revenue year by year. So by another McKinsey report, it is stated that to reach the maximum of the effect, one needs like about 3 years. So, for instance, if you decided to set up some data science department now, your solutions will be integrated into production like in a year from now, and then it will operate and you will reach the maximum of the potential effect in 3 years from now. As far as you could remember, the hype for data science systems was at 2015, I think, and the company worldwide started to integrate the systems after that. And now we have some statistics for about 7 years of. Okay, let us see now to the cost decrease from AI systems adoption. Here we see also the decrease that is more than 10% and even more than 12%. The logic for this slide is similar as for the previous one. We have the same functions as we saw here. We have the same years, but now we have different colors. We have dark gray, moderate gray, and light gray. So the dark gray it refers to the decrease that is less by 10%. By some moderate gray color, we refer to the decrease from 10% to 19%. And for the light gray color is mapped to the decrease that is more than 12%. As we see to the previous slide, now we see the same dynamics. So year to year decrease from the adoption of AI-based solutions, increasing year by year. Okay, so now we have all the background to move to the retail use cases. The cases for retail and quick service restaurants are mostly similar, and their realization is also similar. That's why we could combine these two spheres together. What we see on this slide. This is the retail use cases by function. On the left, we see some functions of the retailer or quick service or restaurant firm. And on the right side, we have some business use cases. So the first function is marketing, the second one is finance, the third one is human resources and operations combined, and the fourth one is R&D, which is research and development. So speaking about marketing and sales, the two common groups of the use cases are assortment and promo planning, and the second one is everything that is related to client analytics. When we speak about finance, here we have two broad subspheres. First one is reporting, and second one is all that related to the pricing. The third one is HR and operations combined. And here we have people analytics and some geo analytics that is related to new point openings. It could be stores or restaurants. And speaking about R&D, which is the last one, we also have 2 points here. First one is video analytics. Second one is natural language processing for different purposes. So let us start from marketing and sales. Speaking about client analytics, we have basically a huge number of use cases, and the first one is all that related to segmentation and customer data marts. What we mean here exactly? Suppose you are a client of some retailer. Your retailer has both online magazines, online shops, and some offline points. And if you speak about online shops, we need to register on the site, and since the registration, you will be provided with some ID number, so that the retailer could identify you. If we speak about offline stores, nowadays there is a modern loyalty programs that also has it also means some registration. So you need to like leave your contacts, leave your name, and maybe some other personal data, and you will be provided with some card and also an ID number that you could show to the store when you visit it, and to receive some points or some maybe another type of the discount. So basically, why we are speaking now about that? So if a retailer could identify you, then the retailer could do some personalization analysis and know you as a customer. And also the retailer could analyze this information in some different dimensions from segmentation too, and make some like conclusions, forecasts, and personalized offers based on this data. So these loyalty programs and registrations basically provide IDs, and when you have these IDs, you could do this personalization. So having IDs and personal information is a prerequisite for any personalization use case. If basically to do personalization, you need to accumulate some personal data. That is logical. And if you want to set up client analytics, the first use case that you need to provide and set up here is customer data marts and then some segmentation. So when this process is finished, then you could see your customer in 4 dimensions. So first of all, of course, you could do some personalized promo. Secondly, you could measure what kind of products your customer already bought in the previous period, and to propose some next best promo for this parts of the customer set. The second main part in this analytics is all that related to the churn. So you could measure the churn in 2 ways. The first is an overall customer churn, and the second is churn by category. The difference is, in the first use case, we are speaking about the complete churn. So suppose that you have a customer, and we have some like simple product retailer, when you could buy some like life valuable products that you need every day, like milk or something like that. So seeing the customer need milk, like sorry. Okay, I'm trying to explain that basically, if you're speaking about some simple standard product retailers, your customer need your products anyway. So if the customer wants to buy milk, he or she will buy it like anyway. So the main question here is where and when it will be. And speaking about the overall churn, we want to predict some probability that some specific customer are going to move to our competitor. And if this probability will be high in some point, we could do some personalized promo in order to make this customer stay. Speaking about churn by category, we usually speaking about our present customers. Suppose that you usually buy, I don't know, water and milk in some specific store, and you do it regularly, for instance, one time per week, and that's it. So you come to the shop one time per week, and buy water and milk. And once upon a time, you stop to buy water. So the main question here for the retailer is, what changed? What actually changed? So it could be changes in the preferences of a customer, or this could simply mean that your customer now is buying water in some other store, yes, for your competitor. And in the first case, when we are speaking about the preferences, about changing the preferences, we can't do anything with that. But in the second case, when your customer decided to buy some specific product, not in your shops but in your competitor shops, we could do something with that, yep, logically. And the technical realization here is the same. As for the overall churn, we want to predict some probability that one of your customers will stop buying one of the common products for these customers. And in this case, again, what we could do with this exactly, we could make some personalized promo in order to make the customer stay and continue buying this specific category of product. Okay, this is all about client analytics. Let us move to not personalized cases, which is assortment planning and promo. So what we have here? Okay, basically here we have four most common use cases. First is customer decision trees. I would explain later. Second one is the mass promo planning. The third one is assortment matrix optimization. And the first one is product recommendations for e-commerce. So what is customer decision tree and why it's important? Again, suppose we are some retailer and we have an assortment matrix. What is this? This is just our menus or something, so just a list of all our products that we sell. And we have customers on the other side. Suppose that the customer want to buy milk. We know that that is a range of the different units of milk with different properties in our store. And this assortment could be divided by price, by any other conditions, and we want to know how our customer make a decision which milk exactly to buy. What we can do as an analyst to provide these explanations. We could have ideas or even not, but we have some checks from your shops, and just by using this data, it could be both personalized and not personalized, but you still could see some conditions via segmentations. And by combining some customer segments and their actual preferences, we could set up some tree, and according to the weights for different leaves, we could set up some further analysis about how to and in which proportion to combine our assortment metrics. Let us move to the mass promo planning. This is some kind different from personalized promo, and the difference is actually we want to set up some promo plan in some period to the future from now. So suppose you are a marketing manager and you have some sales forecast for the next year. And this marketing manager could see that, for instance, we have some decrease in the summer and we have some increase in the sales before the new year, and maybe for some different points of time, and we need to optimize our stock and sales. So in the periods when we see the decrease in the sales, we could plan some promos, like some discounts or something like that, in order to optimize or even maximize sales in these periods. What is assortment matrix optimization? Here we usually speak about the purchases of the products for the store to some period of time in the future. Maybe if you let me provide some example. Suppose we have two types of product retailers. The first one is some mega markets that is usually located outside the town, and the second one is a usual supermarket, some small shops. And it's logical that for the large like megastores or something, the number of the products will be much more greater than in the local store. And we, as a company, as a retailer that is having both types of points, want to know exactly which products to place in the specific store. How we could do that? We could analyze sales, especially checks, and see what is the distribution of the sales in SKUs or units for some specific products, both in category and by segments of your customer. And according to this information, we could purchase some specific products for some stores and not to purchase for the others. This is basically about assortment matrix optimizations. Of course, it could be done using some simple retrospective analytics, but also with predictive analytics. And the fourth use case here is product recommendations for e-commerce. So suppose we have some online store. Suppose we are going to the site of the store and see there some window when we could put an information about what product you want to buy. And then after that, you will see the list of the available products. Besides of the fact, have you registration or not for this e-commerce shop exactly, but after you insert even this information about one first product, then the list of the products will be optimized in order of your behavior on this site. What other information is important here? How much time you usually spend on one site page? What is the movement of the mouse on the page? And what logic is behind the selection of the specific product on the site, even before you buy it, anything? And using all this data, combine the internet shop, I'm sorry, could provide some products for you that will be like the most useful. And this could be done via some common segmentation and also via your personal data. That was all about the marketing use cases, and now let us move to the finance use cases. Okay, here we have basically three, but I will explain just two today cases. And the first one will be reporting, the second one is forecasting, and the third one is pricing. So what could be done for reporting? Here we have also three subparts. The first one is reporting automation, the second one is all about the visualization, and the third one about fast closing. So speaking about reporting automation, we just mean that we don't want to ask an analyst to calculate some numbers for you for your reporting, like each time in some period. We just want to make some code that will allow us to automate this process. This is about the automation, and the second point is visualization. Why I provided the visualization separately from automation? Because choosing the best visualization depending on your internal customer is crucial for business. So suppose you have some top management, you have some middle management, and you have some specific analytics team that is used data from the past period in order to optimize their operations. So for top management, you usually need some specific executive information that need to be visualized in a certain way. For some middle management, you will need some you'll need more details, and you will need some more explanations about why something changed in the past. And regarding some specific analytics team, you will need like thousands of detailed reports that is linked to some weights and to some technical details that is specific and is valuable for this specific analytics team. So the visualization could be done in a very different ways, and depending from the needs of your internal customer, you need to choose the right way to visualize some reports. That's why retailers, and not only retailers, because finance function are presented like in each and every company, there is a separate team that concentrates on the visualization of reporting. And of course, these teams are connected to the automation team. Let us move to the third case here, which is fast closing. So what is this exactly? Suppose you need to provide some executive report to top management for the last month or for the last quarter in the beginning of the month. But for some reason, it technically could be done only like to the end of the first week. If we speak about retailers, we operate with products. These products could be changed, they could be returned, and the clean data with these returns, changes, and so on, usually like need some time to be collected. And it becomes, because of that, we also need some time to like make final calculations. And suppose that it's possible to provide clean reports after all these returns and so on, only like for seventh day of the month. But the management want to see some dynamics for the third day. How we could do that? And there are some solutions for this problem. As I was saying previously, we have like basically two types of purchases by customers. The first type is when you purchase a product and stay with this product, so everything is good. And the second type is not everything is good and you need to make some change, or you as a customer need to return some specific product. So in terms of the reporting, we are fine with the first part, when customer bought something and stay with it. Yep, and we have some problems with the data, with these changes and returns. And what is the solution? Having relatively big amounts of the previous period data, we could forecast the number of your returns and changes. And this forecast, using nowadays the modern data science methods, could be done very precisely. And you could use these forecasts in order to make your reports faster. And then after doing that, you also could change the numbers on your reports in the next period when the actual data will come. Okay, we were speaking about the reporting, and now let us transfer to forecasting. So forecasting is a very, very special use case. Actually, this is important not only for finance but for other functions as well. And the most important part here, that this is not just one model. The forecasting could be done in many dimensions. 4 of them are as follows. The first one is by time frame, the second one is by location, second by target, and the fourth one by category. Let me explain here. So regarding the time frame, there are 3 types of forecasting. The first is long term, the second one is moderate or mid term, and the third one is short term forecasting. Speaking about long-term forecasting, we usually mean that we want to predict some specific value for 1 year to the future, or for 2 years, or like more than 1 year. If we speak about short-term forecasting, we usually want to predict some values in an hour ago, or in an hourly time frame for a week ago. And when we speak about moderate term or mid-term, we mean anything that in the borders from 1 week to 1 year. So that could be done like weekly for 1 year, weekly for 1 week, weekly for, excuse me. Sorry. Yeah, so about moderate or midterm timeframes, the forecast could be done for a week ago, for a month ago, for a quarter ago, and so on. And also here is important the frequency of these reports. So even here we also have some mixes. Next, let us move to the location part, and as far as you understand, this will add some complexity to the time frames. So speaking by location, we could do forecast to the overall firm. On the other side, we could do it by points, by restaurants, by stores. We could do these reports and forecasts also for some specific customer or group of customers here. And all of this dynamics is related to the location. So it's not just about some region. It starts from the customer and store level and ends to the whole firm level. The next level of complexity here is target. It could be money. That is the most interesting part for the finance department, finance function, and it also could be done in units. The units part are usually more interesting for marketing or operations departments. And the fourth level of complexity here is category level. So, for instance, we could do some forecast for some specific milk that is provided by some specific from some specific firm, and we could do it for all the category milk, we could do it for the category milk and something else, and like that. So we have at least here 4 points of dimensions, and if we start to mix the different parts of these points, we could end up with like thousands of models. And usually, speaking about the setup of the forecasting departments, we have here like from 3 to 10 different teams that specializes on forecasts for some specific category or even time frames. What else could be added here, and what is important to understand? So basically, let us now look to the third point, which is target. By target, again, we mean that we want to provide money, or we want to forecast some number of units, for instance. And one could ask why we just can't convert unit forecasts to the money, because we know the prices. Logical questions. Yep, it's logical. But what we have in real life? When we speak about forecasting, we also speak about some forecasting accuracy. We can't forecast with 100 accuracy or something like that. We have some uncertainty here, and it could be under forecasted or over forecasted, and then we have some like average mistake of the forecasting here. And this average mistake of the forecasting, it's not constant in the time. So case by case and model by model, and even prediction by prediction, this mistake could vary, and this variation could be like very, very different from time to time. And if we just use prices to convert this forecasted unit into the money, we increase our cumulative mistake. That's why it's like it is proven that this is more efficient to do separate models for forecasting in money and for forecasting in units or some other. This is basically all about the forecasting, and now let us move to the human resources function. And I also need some water. Okay, then, HR analytics isn't very special for retailer sphere. It could be done in similar ways for any other types of companies. And what cases could be solved here? So the first case is CV scoring and probation forecast. What we mean here? Suppose we have some candidate, and before we even contact with this candidate, we want to know the probability about how he or she exactly will work or fit to our company. Why this use case important? Suppose we have a huge company and we have position with like many candidates that want to reach this position. And we, in order to interview all these candidates, we will need like a huge amount of time, resources of HR specialists, for managers, analytics, and so on, just to be sure that some specific candidate will reach some like level in this pipe. And what we could do with this? We could automate the first several levels of the pipe and make interviews only with some final candidates. And yep, this could be done with machine learning. And how exactly we could do that? So regarding the CV scoring, suppose that we have a big enough company with some saved HR data. So we know that, for instance, some specific analyst that is working for us like for 2 years or for 3 years. We see his career path. We know what, I don't know, learning courses he already started in our company. We know the history about how this analyst was moving in our company from time to time. Even we also have his like starting CV. Okay, we know the data. We know how this specific person how productively actually he worked for our company. And now suppose that we see the CV from some candidate that want to reach the position, some analytics position. We could calculate and analyze how the background of this specific person is similar to some another successful analyst that is already employed to our company. And according to this score, we could recommend the final manager to like range the candidates according to the score and set up interviews with like the most scored candidates. This is about scoring, basically. What else could be done here? Speaking about the first level of the pipe, when we, like, suppose you send your CV to some company and you are invited to the like first level of the interviews. It could be testing or HR interview or anything. So both testing and both HR interviews could be automated as follows. We could ask our candidate to do some test online or to even answer the questions for the camera online. And then we could automatically, using Videoanalytics and combined with natural language processing techniques, we could analyze all these testing and camera data and make some scoring also that later will be provided to the manager, and also also to be able to range the candidates. About the probation forecast. Now, what is probation? It could be different country by country, but what we have in Russia. what we have in Russia. Usually, when you confirm the offer of some firm, then you start working, and you are provided with 3 probation months. And after this probation period, some committee usually set up that concludes about how productive you are, basically how good are you for this specific company, and then your position and your offer are finally confirmed. So what's important here? The company, from the side, from the view of the company, they are interested in providing offers, some initial offers to the candidate that is more likely successfully pass this probation period. Because if it won't be successful, the company will need to search for some other candidate, and the work will not be done for this specific period, and like matching many resources of HRs and so on will be used. So it's not optimal. How we could optimize this? Also by having personal and working data of the workers of the company, of the employees, we could estimate how a specific candidate would behave on this probation period. And having these probabilities, we also could range our candidates. Okay, now let us move to the employee churn. This is another interesting, from my point of view, interesting use case. What we want to know here, suppose we have some IT department, and we know that the demand for IT specialists is very, very, very high. It's hard to find, engage, and make the specialists stay for a long time in the company, and we want to make like life of these employees good in our company in order to make this specific employee happy and stay with us. What we could do, having some behavioral data of the employees. Basically, we could estimate the probability of the willing of the specific employee to leave our company for some period of time. Even before this specific employer realizes that he wants to leave the company. How we could do that? Basically, we will just need some tracking data from the different systems in our computers, like the number of logins, the time of logins, the number of emails, the number of meetings, the number of even movement of the mouse. And the most important predictor here is the changes in these aggregates employee by employee in time. So when your behavior changes, it means that something changes in your mind and in your living process and so on. Of course, it could be related to any other reasons, but there is, and there are some specific patterns that is related to the willing to resign. And in order to create this model, you usually just need to have 1 or 2 data scientists in your team. So it's more than possible, and for good reasons and for a good time. Okay, let me turn to the third point. The third point is learning recommendations. Suppose you have salespersons in your retail stores. The salesperson is some consultant that come to the visitors and saying like, what are you searching for? Can I recommend you anything like that? And suppose that these salespersons operates in a different way, and even in terms of efficiently. So suppose that we have like some not so efficient salespersons in terms of, for instance, weekly revenue generated, and we have some like middle salespersons that make a plan, and we have some overperformers here. And also we have some statistics about how they operate, how they sell, and also we have some background information and some dynamics of the passing of learning courses, salesperson by salesperson. So next we could apply the same logic as for recommender systems for the sites, I mean for the online shops. And the logic is as follows. We have some overperformers, we have some underperformers. Let us look how what is similar between them and what is different, and according to this information we could recommend some different learning paths for underperformers to make them overperformers. Also, this is a common task and successfully solved. Let us move to the first use case here. This is the heat maps of the relationships between the departments, and the motivation is as follows. Actually, we as a human resources department want to make the life of our employees better, and we also know that some conflicts or something like that usually lead to the decrease of the involvement of the employees, which is consequently leads to the increase of the probability of the willing to leave the company, and we want to minimize it, of course. So how could we know that there is some problems in the relationship? Basically, we could make some analytics report that is called heat maps, and even we could provide the dynamic of these relationships to some point of time in the future. What data we need to have in order to be able to do that? Basically, we just need access, and basically we have access to some like written-based information. So we have emails, meetings, and so on, and other documents, and we know how these documents are distributed between the employees. And the second important part, what we need to have, is some natural language processing specialist to be able to analyze sentiments here. And by how the statement, by how the sentiments changes in time, by this information we could like make some conclusions about when we will reach some scandal or something. And in order to minimize, we could contact some HR business partner to make some interventions in this process. Okay, the fifth use case here is an analysis of the influence of personal involvement factors. So what is involvement? Involvement. In Russian, it's вовлеченность. It is just a measure about how much happy is some specific employee. And there was a research by McKinsey about the involvement, and from which we could conclude that employees with a relatively high level of involvement like make in 10th or even 12th value to the revenue or some other important financial results than the employees with a relatively low level of involvement. And in order to analyze how exactly in our company and the involvement relates to the financial results, we like do some data science analysis. Let us move to the R&D part. I think I'll proceed briefly because we are short in time. I also want to leave some space to the questions. Actually, what is R&D in retail? In the beginning of this presentation, we saw some motivations to develop any data science use cases, and we saw that there are basically two types of this motivation. The first one is increase in revenue, and the second one is a decrease in costs. And before starting to develop anything, we need to estimate the potential effect in terms of revenue or in terms of cost reductions, to be sure that we won't waste time for the development. Logical. So what is the place for R&D? We relate some use case to the R&D when we potentially feel that the realization of this use case would be valuable, but we don't have a specific argumentation for that. Basically, I mean that we just feel that something will be valuable, but we are not sure. We don't have background for some specific use case. So all the use cases with not confirmed potential positive effect will be related to the R&D department. Okay, and what we have here for retailers? What we have here for retailers? Video analytics and some speech and text analytics are based here usually. Basically why? So as far as you see from the slide, you see that all these are related to the processing of the videos. And suppose you have just one store, offline store, physical store, and in order to be able to analyze behavior of your customers in this one specific store, we need to analyze the data from 5 cameras at least. And the recording is a continuous process. And as far as you understand, this is a huge amount of data, even for one store, for 1 hour. And the second point here, besides of the amount of the data, is the cost of the internet channels for the stores. So, for instance, in Russia, we have a relatively cheap internet for like physical users, for homes, for like me and you, and we have relatively overpriced internet access for commercial purposes. And these prices makes all the analytics not effective in terms of money. But this is just for now. So we know that we have here 2 problems. First is the amount of the data, and the second one is the price of the use case. And we could feel that for the future, when the prices may be lowered, we will make these use cases like more efficient, and we could transfer the realization of one use case for one specific store to like some many stores. And this is basically the main reason why our retailers have like 1, 2, I don't know, 3, but not more than 5 such called pilot shops, pilot points. Because it's fun and it's nice to make all this kind of analytics, but it's not efficient in terms of money. So they can't make it to all the retail network. Okay, now let me briefly describe the cases regarding speech and text analytics. So here we have 3 cases. The first one is voice assistants. This is usually used by call centers in order to minimize human resources here. The second part is different chatbots. It also could be used for on the client side or in the internal use purposes. And the third point here is some advancements to the scripts of salespersons. And in my opinion, the third is like much more interesting in terms of the research. Okay, we have like, I don't know, 4 minutes left. And I try to explain fast. So I know that all of you are interested in the development of your career in the data science. And now you could be already studying data science, so you could just think about should you move to this industry or shouldn't. And I would like to explain if you decide to become a data scientist, what will be your special place in some product development team. Okay, so what is the typical product team setup? The team usually consists of a product owner, which is a manager of a small team. So what is a product? Suppose we are suppose we are, I don't know, a team that develops forecasting model, or we are a team that makes reporting automation or something like that. Each that level of team will consist of at least 8 teammates. So the first one is product owner, which is like a head of this team. Also, we would have project managers who make some important support in order to make the development process like more productive. And we have some technical specialists on the data side, that is ETL and data quality specialists. And we have at least 4 different specialists for model development part. This is data analyst, business analyst, data scientist, ML engineers, and many more. So in order to understand which part of the development is yours, let me show you the product development pipeline. So suppose you will listen this webinar and decided to come up to your manager with some idea. Suppose you come to your manager like tomorrow and are going to say, let's develop some forecasting model. So your manager, first of all, would ask you why we need this model and what potential effect this model bring to the firm. So these two parts are presented as the first 2 points on this slide. So first of all, before we start to develop any model, we need to understand what business problem could be solved by this specific model. Or vice versa, we could have some business idea. It could be even like that. So I heard that nowadays data science are going to make great impact, and we want to, I don't know, increase sales by integrating advanced analytics. But how exactly? We don't know on this point of time. So we need to connect our business problem to the technical problem and vice versa. And this will be the first point to think about when we're talking about the development of any analytics use case. So after we defined our business and technical problem, we need to think about what metrics we will use, both business and technical, to measure the performance of this model and to measure the performance of the whole use case, because one use case, business use case, could be solved by one or by a number of models, and vice versa, one model could be even a prerequisite to develop many business use cases. So we need to define all of this, and only after that we proceed to the development. So the development starts from the third point on this slide, so from the data set preparation, and ends on the code production. And your part explicitly would be from the third point to the last point of this product development pipeline. This is just to remember that data science consists of three dimensions, subdimensions, which is mathematics, computer science, and some domain expertise. So let us see how many different data science positions are related to this sphere. So here we have triangles with mathematics development on the right, which means computer science skills, and the third dimension is some domain knowledge. So these three dimensions are the same as here: mathematics, computer science, and domain expertise. And we could see that there are at least 6 different roles, different technical roles in a team, and the difference between these roles are about the difference is all about the focus or special skills of the data scientist. So let us see the first triangle, which is ML engineer. So we see that ML engineer would have more background for the would need to know more background between mathematics and computer science skills, and like less knowledge of the domain. And explicitly for analysts, it's crucial to know your domain field, and but analysts could have like moderate skills on mathematics and computer science. So basically an analyst by default like should how to say it strictly. So an analyst could, like simple analyst, even could do his analysis like using Excel or something. So the Python knowledge or even SQL language is not the prerequisite for analyst, but the deep knowledge of domain expertise is a prerequisite to become an analyst. So this is just how to read this slide, and let me finally finish this presentation. So thank you all. If you would have more questions, you can write me to the Telegram. And now I will stop the demonstration and we'll read your questions. Okay, so Margarita, could you please help me with questions? Looks like there is no questions. Yep. Oh, one question is here. The question is from Ali. He's writing that, hi, he's a former software engineer that is studying data science right now. Which position would you recommend? Ali, basically, this is hard to answer just having your background as a software engineer. So from this point of view, from just only this point of view, I would say that any of the 6 roles could, like you could apply for any of these 6 roles. But this is more up to you. What kind of this role will be interesting for you exactly? So what's your like feelings about that? So basically, I think that after the completion of your data science degree, you could fit for all the 6 roles, and that's not a problem. Some other questions? There is another question from Igor. So the question is, as a specialist, what do you most like to spend your time on? Igor, is it a question for me exactly, or this is a question about the time distribution when you are like a junior, middle, or senior specialist? So if Igor, the second part was meant. Нет, не все. 5 минут. I'm sorry. 5 минут. Sorry for that. So basically, if you are a junior, middle, or senior specialist in data science, I mean, you are a data scientist, you are a researcher, a ML engineer, or anything else. So the distribution of your working time would be as follows. Like 20% for data analysis, preparation, and so on. About 40% for modeling, came up with the best model and something like that, so writing the models, and about 40% for testing of the good, mathematically good model. Because if you model good mathematically in terms of mathematical metrics, it's not like you couldn't be sure that your model also good in business metrics, and vice versa. You could have like some weak data science model, but even this small like addition from even a small addition from the random guess to some knowledge may lead to a huge increase, for instance, in net sales or some other business metrics. So you don't know this before you do some research. Good point here that like in 15, on average, in 15 years from now, we would have some statistics about how like some specific model behave on testing and production stages. Okay. Next question from Valery Labanov. Will you please provide an example of the problem in retail nowadays which are yet unsolved? Okay, I understand your questions, but I would like to add some specifics. So, what is solved and what is unsolved? What is solved? So, if you think that, for instance, if you have some good enough model, for instance, forecasting model for some retailer one, you could simply transfer this model to some competitor of this retailer, or even for, I don't know, some simply in other store, even in your network. So you are wrong. You are wrong. Surprisingly, even with similar amounts and similar structure, the data, it's hard to transfer the developed model. So you need to start from the data analysis, from the distributions analysis, and so on. And so basically, if we know how to solve the solve the problem, so we know how to solve it in terms of machine learning design, you still need to retrain your models, and in some cases you even need to come up with different ML design. And this is just because the distributions of the data, of the subparts of the data, are very different even for like same companies. Okay, the next question from Vladimir Mikhailov. So the question is why we are getting more close and close to Skynet. I mean, there are known concerns like GPT. Yep. Basically, me, my colleagues and friends also have these concerns, and we are in the point of studying and estimation of the potential effect. So, yep, there is some like valuable point. We live in some valuable point of time when we have transformers for NLP, we have diffusion neural networks for computer vision that could generate nearly everything and do it fast. And regarding the GPT, yeah, of course, this like kind of architectures, of course, more than valuable, but we for now we don't know exactly how it will change the industry and how it will change our life. But we will come with these reports, I don't know, like in a half of the year. Okay, the next question, what's going on there? The closure of the webinar for data science and retail. This is basically for Pavel. Okay, the next question from Asif. Do we get certification for these webinar participations? Basically, I have no idea. You should ask somebody else. Okay. Any more questions? Any more questions? From Mohammed, how are data scientists involved in developing LLMs? Mohammed, could you please explain what LLMs is? I don't know what that. Large language models. So basically, if you mean by large language models something like GPT-3, 4, and so on, so primarily data scientists study how to apply an already developed architectures to the specific language corpuses, because like weights, even substructure of the networks could vary dramatically from language to language, and even from some subparts of a language. So some architecture, I don't know, for the science fiction could be different from the architecture, I don't know, for the some scientific literature. Okay, many more questions. Any more questions? Okay, so if you lately would have some questions, you could write me to my Telegram. Please don't write me to my official Higher School of Economics email, because I don't read it. But you could write to my personal email, which is polina.polunina@yandex.ru. And see you soon.